This video is on the unit circle and how it works. First thing you need to understand is circumference of a circle is 2 pi r. Circumference is like if you walked around the circle. The degrees in a circle are 360 degrees. All right, in the unit circle, the radius of the unit circle is 1. So I draw this green triangle as if you're going from like this point right here would be 0, 0, that red dot I drew. That would be 0, 0. So this would be the x value, and always y is the vertical value. In a circle, we'll call this diagonal the radius, or r. So I always, when I write sine, cosine, and tangent, I always write sine first, cosine next, and tangent next. Because when you get into higher trigonometry, sine divided by cosine is tangent. So if you look back at this triangle and you go, what is sine of the angle? The angle was theta. Sine of theta. Sine is opposite. So sine of the angle is opposite over hypotenuse. So y over r, but r is really 1. Cosine of the angle is adjacent over hypotenuse, so x over 1, or x over r. And tangent would be y over x. Okay, I always think about the degrees. The degrees start at east. 0 degrees. I count around, I fill out the bigger ones first. So 0, 90, you go around counterclockwise, 180, 270. Then I'd fill out all the 45s. 45, if you add on 45, you get 90. If you add on 45, you get 135. If you add on 45, you get 180. If you add on 45, 225, 270, 315, and back to 360. So the 45-degree angles are really 45, 135, 225, and 315. The 30-degree angles, you could count around 30, 60, 90, 120, 150, 180, 210, 240, 300, 330, 360. So they're called reference angles. Reference angles means in reference to the x-axis, so how far away I am from the x-axis. So if this is 30 degrees, in the second quadrant, the angle is 150. That is 30 degrees from 180. In the third quadrant, it's 180 degrees to 210. In the fourth quadrant, 330 is 30 degrees away. So those are all the 30 degrees. The 60 degrees are 60 degrees away from the x-axis. They're all orange. 60 degrees. 120 is 60 degrees from 180. 240 is 60 degrees from 180. 360 are 60 degrees away. All right, here's how you convert from degrees to radians. Circumference equals 2 pi r. Right? All right, so that is equivalent to 360 degrees. So then you solve for pi, and to solve for pi you divide by 2. So you get pi is equivalent to 180 degrees. So the fraction pi divided by 180, because that's kind of like saying 1, that's how you convert from degrees to radians. So how I did it is I took 60 degrees and I multiplied it by pi over 180, and I got, you put that over a 1, and you get pi over 3. So 60 degrees is pi over 3. 45 degrees multiplies out to be pi over 4. 30 degrees becomes pi over 6. 90 degrees becomes pi over 2. These are called radians. So one thing you do is you can count around by radians. So I'd start at 0. Let's start at 90 again. 0 is, and then pi over 2, because that was 90, was pi over 2. If you go to 180, you get 2 pi over 2, but that simplifies to 180. That's how I always tell if I'm correct. It has to simplify to pi, because 180 and pi are equivalent. Then I go 3 pi over 2, which is 270 down here, and 4 pi over 2 simplifies. Okay, then you get, let's do pi over 4. So all the 45 degrees are pi over 4. So pi over 4, they're purple. 2 pi over 4 is 90, and that would simplify to pi over 2. 3 pi over 4 is purple. 4 pi over 4, oh, I'm doing it right. 5 pi over 4 is in the third quadrant. 6 pi over 4 is at the bottom. That reduces to 3 pi over 2. 7 pi over 4 is fourth quadrant, and 8 pi over 4 reduces to 2 pi. So those were all, purple was all the 45s. Let's do all the 30 degrees. Okay, they're all blue on here. And 30 degrees is pi over 6. So pi over 6, you would call 60 degrees 2 pi over 6, and that reduces to pi over 3. So I really call, if I just count around by 30 degrees, this would be 2 pi over 6. But then that reduces to pi over 3. And then 3 pi over 6 reduces to pi over 2. 4 pi over 6 is right here. It reduces to 2 pi over 3. 5 pi over 6 is in blue again, is the one you really write. 6 pi over 6 is 180. 7 pi over 6 is blue. 8 pi over 6, that would reduce to 4 pi over 3. 9 pi over 6 would be 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3, it's green here. And 11 pi over 6. So all the green are the reduced 60 degrees. They are all 60 degrees. And all the blue ones are 30 degrees. And next I'm going to show you how the ordered pairs work. The ordered pairs follow these special triangles, special right triangles. So the 45-45 triangle, 1, 1, root 2. We've already learned that, right? If you do, if you remember back to here, that sine was y and cosine is x, that's important. So if I go sine of 45, I go, oh, 45 degrees. Sine is opposite over hypotenuse, 1 over root 2. But you should always rationalize the denominator. So root 2 over root 2. All right, and then cosine of 45 degrees, 1 over root 2. You rationalize the denominator again. So all the 45 degrees are going to be root 2 over root 2. And the only thing that will affect them is what quadrant you're in. So if I'm in the first quadrant, remember that x is cosine and y is sine in this ordered pair, x, y. I memorize it, c comes before s, so c cosine, y is sine. All right, so in the second quadrant, x is negative and y is positive, so you make your ordered pair. The x is negative and the y is positive. In the third quadrant, they're both negative. The fourth quadrant, x is positive and y is negative. The other ordered pair comes from the 30, 60, 90 triangle. I always draw this triangle off of the 0, or off of the origin, 30 degrees. And you'll remember that across from 30 is 1, and across from the 90 is 2 in blue, and across from 60 degrees is the square root of 3. All right, so, but this picture shouldn't really make sense because I told you guys that the radius is 1 of the unit circle. Well, so in order to make it 1, you just divide by 2. Let's turn it into 1. So 2 divided by 2 turns into 1. So now my radius is 1. My x value is square root of 3 over 2. My y value, this is y, the y value is 1/2. Or you could go cosine is of 30 degrees is square root of 3 over 2. Back to the blue numbers. Or sine of 30 is 1/2, so y. And then I put them on the unit circle. I just made sure they all have the signs. First quadrant, your root 3 over 2. Second quadrant, x is negative. Third quadrant, they're both negative. Fourth quadrant, y is negative. All right. So the green ones are the 30 degrees. The 60 degrees work exactly the same way, except they are the different angle, so you flip the ordered pair. And then you put all the 60-degree angles in, same way. So here the next one would be 120, negative 1/2, root 3 over 2. Then the next one, 180, right? And then 240. Look down here. Is both of them negative, right? Negative 1/2, negative root 3 over 2, and then 300, right? I'm not going to do that one because I'm running out of space, but this shows the 60-degree angle and how you get the ordered pair. And you got to make sure the unit circle goes right on to the Cartesian coordinate graph, where this would be x and y. All right. That's it. Good luck. You got this. The unit circle. How it all works, the unit circle.